Insecticides destroy the central nervous system by affecting critical molecular targets essential to nerve functions. We previously discussed inhibition of acetylcholinesterase by organophosphate and carbamate insecticides, and the hyperstimulation of the synaptic sodium channel acetylcholine receptors by neonicotinoids. We will now discuss hyperstimulation of the axon sodium channels by synthetic pyrethroids. Pyrethrins are natural insecticidal chemicals extracted from pyrethrum flowers which are related to chrysanthemums. Synthetic pyrethrin mimics are termed pyrethroids. Here is a neuron. This section from an axon membrane shows the organization of the membrane and the molecules that affect sodium permeability. We discussed earlier that cell membranes are naturally impermeable to sodium. Because positively charged sodium ions cannot enter the cell, the outside of the cell is positive compared to the inside, which contains many negatively charged molecules such as proteins and metabolic products. However, sodium channels that open and close to allow sodium entry are present in both the axonal and postsynaptic membranes and make the membranes electrically excitable. Synaptic sodium channels open in response to neurotransmitter chemicals. Axonal sodium channels open in response to negative depolarization on the outside of the axon membrane. The action potential progresses down the axon as a negative wave that is formed as sodium channels open to allow sodium diffusion into the axon. Behind the action potential, the outside of the axon membrane regains its positive charge as the sodium channels reclose and the sodium pump transfers the internal sodium ions to the outside of the axon. In this way, the region of the action potential is propagated along the axon. Let us now see how pyrethroid insecticides exert their effects on axon sodium channels to cause insect paralysis and mortality. Pyrethroids interact with the open sodium channels to hold them in their open conformation. At first, the open sodium channels allow sodium ions to enter the axon continuously, which produces excessive action potentials, followed by a hyperdepolarization of the membrane. Finally, the charge on the axonal membrane disappears as the numbers of diffusible ions are brought to a state of equilibrium inside and outside the cell. Let us observe these effects at the neuron level. Pyrethroid-treated neurons exhibit uncontrolled firing and neurotransmitter release